RAG, or Retrieval-Augmented Generation, has become one of the most popular architectures for building generative AI systems. The idea seems straightforward. Retrieve relevant documents, provide them to a language model, and generate answers grounded in real information. But when teams deploy RAG systems in production, many of them run into problems. In this video, we'll explore why RAG systems often fail in real environments and what teams can do to fix these issues. Let's start with the first major problem: poor retrieval quality. Many teams assume that once documents are embedded and stored in a vector database, retrieval will work automatically. In reality, retrieval quality is one of the biggest bottlenecks in RAG systems. If the system retrieves irrelevant documents, the model will generate answers based on incorrect context. Even the best language model cannot produce reliable answers if the input information is wrong. The second issue is document chunking. When preparing data for retrieval, documents are usually split into smaller pieces called chunks. If chunks are too small, important context can be lost. If chunks are too large, retrieval becomes less precise. For example, imagine retrieving half of a policy document without the section that explains the exceptions. The answer might sound correct, but it could be incomplete or misleading. Another common problem is evaluation. Traditional machine learning systems have clear evaluation metrics like accuracy or precision. RAG systems are harder to evaluate. Because they involve both retrieval and generation, it becomes difficult to measure whether problems come from the retrieval system or the model itself. Many teams rely on manual testing instead of structured evaluation pipelines. This makes it difficult to track improvements over time. Latency is another challenge. A RAG system includes multiple steps. First, the query is embedded, then the vector database is searched, then documents are retrieved. Finally, the language model generates a response. Each step adds processing time. At small scale, this delay may not matter, but in large production systems, latency quickly becomes a serious user experience issue. Cost is another hidden problem. The more documents you retrieve and include in the prompt, the more tokens the model must process. This increases inference cost. Without careful optimization, RAG systems can become expensive to run at scale. Another challenge is data freshness. Company policies, documents, and knowledge bases change frequently. If embeddings are not updated regularly, the system may provide outdated information. This reduces trust in the system. So, how do companies fix these problems? First, they treat retrieval as a critical component of the system, not just a simple pre-processing step. Teams experiment with different chunking strategies and embedding models. Second, they build evaluation pipelines to measure both retrieval quality and answer relevance. Third, they monitor system metrics such as latency, cost, and user feedback. Finally, they continuously update and improve their data pipelines. The key takeaway is this: RAG does not fail because the concept is flawed. RAG fails when teams underestimate the importance of system design and operational practices. Understanding these challenges is essential for anyone building real-world generative AI systems. If this explanation helped you better understand production challenges in RAG systems, subscribe to Practical Gen AI. I share practical insights on generative AI systems, architecture, and AI careers.